Let's study 10th standard ICSE Physics, Chapter 10, Electromagnetism, the parts which were not covered in the previous video because of the reduced syllabus. So we'll study simple DC motor, AC generator, and transformers. These engineering marvels, how do they function? So let's start with DC motor. It is based on Fleming's left-hand rule, which says that if you have your forefinger and your central finger mutually perpendicular, and the forefinger represents the direction of the magnetic field, and the central finger represents current, then the thumb, which is mutually perpendicular to both of them, will denote the direction of the motion or the force being applied, the Lorentz force. You see, the current has its own magnetic field, and when a current is flowing in the presence of another magnetic field, that current carrying conductor will experience a force which makes things move, and that's how a motor works. Motors are useful in fans, washing machines, juicers, etc. Here, the electrical energy is getting converted to mechanical energy. So the principle has to be studied. Now, the construction is just read. You don't have to learn it. Double tick this diagram. You have to practice this. It won't come for drawing, but drawing is the best way to understand how it works. You should watch the three-dimensional videos available on YouTube where they show how it works. Now, we have this soft iron core, which makes the magnetic field stronger. North pole and south pole of a horseshoe magnet. This is a wire, A, B, C, D. It's called the armature coil. We have split rings. The ring has been split into two halves. They are in contact with the carbon brushes, due to which the circuit is completed, as they are connected to this external circuit, which has the key, battery, rheostat to change the amount of current flowing. So right now, if I draw arrows, the current is flowing in the direction A, B, C, D, and coming back and completing the circuit. Just focus on AB here. Direction of current is like this. And magnetic field is always from north pole to south pole, so like this. So they're perpendicular to each other. So if the field and the current are perpendicular to each other, what will be the direction of the force? So the magnetic field is a forefinger, something like this. And the central finger tells us the current. Well, current is upwards, AB, right? So like this. So that means the thumb represents the motion, so it's downwards. It's perpendicular to the plane of the paper inwards. So the AB will go in. So imagine that this edge is AB, okay, and this is the armature coil. So AB is going in, so it will start rotating like this. Because on CD, the direction of current is towards me, like this. And magnetic field is still from my left to right. So now the motion is upwards, the force is upwards. So AB is moving downwards and CD is moving upwards. Hence the rotation, from my perspective, is anti-clockwise. The working is also read. Only application-based questions will come, for which the solved examples and the exercise questions are enough. It covers everything. Notice how in this diagram, initially when the coil was parallel to the magnetic field, it experienced maximum force. Let's say the angle here is 0 degrees. Now when it rotates and becomes perpendicular, something like this. So now it's perpendicular. So that's 90 degrees angle. Here is that the split rings are no longer in contact with the carbon brushes. Notice here they were in contact, but now it rotates anti-clockwise, right? So this goes up and this goes down, something like this. And this is also 90 degrees perpendicular to the paper here. So since they are not in contact, the current stops flowing. But due to inertia, it will continue rotating further. So at 90 degrees, the magnetic field is minimum, the force is minimum. Now, due to inertia, when it completes a 180 degrees, once again, the split rings are in contact with the carbon brushes. But notice that here, S1 was in contact with B1, and direction of current in AB was northwards, like this. And here, after a 180 degree turn, S2 is in contact with B1 and S1 came here. And now it's DCBA, current is flowing from DCBA. So in AB, the current is southwards, and DC, the current is northwards. But the direction of rotation will be the same, it will still rotate anti-clockwise. But the direction of current has changed. Earlier it was ABCD, now it is DCBA. Of course, the direction of current in the external circuit is still the same. And then at 270 degrees, again, same as 90 degrees, the contact is broken, but due to inertia, it will continue to rotate. So the note says that the deflecting couple on the coil of the motor is maximum when the plane of the coil is parallel to the direction of magnetic field, 0 degrees and 180 degrees. And the couple is 0 or minimum when the plane of the coil, this is the plane of the coil, is perpendicular to the field of the magnetic field. How to increase the speed of rotation? Well, there are 4 ways. Increase the strength of the current, increase the number of turns in the coil. We just saw one coil, one rectangular coil. Third, increase the area of the coil and increase the strength of the magnetic field. And to increase the strength of the magnetic field, one technique is to put a soft iron core, which has one more advantage. It makes the magnetic field strong, of course, and radial also, which is not so important from exam point of view, of course, but from engineering point of view, it's very useful because it makes sure that the magnetic field remains constant as it is rotating. You see, as it rotates, the magnetic field should remain constant except when it is perpendicular. What is the function of the split ring? Oh, that is an IMP question. Let's read it. Whenever the coil passes from the vertical position, the direction of current through the coil has to be reversed so that the direction of rotation is the same. So if the current from ABCD becomes a DCBA, only then the rotation will continue to be anti-clockwise. And this is done by a split ring commutator. Next topic is AC generator. Double take it and practice it. Notice that this diagram is similar to the DC motor, but there we had used split ring and here we use slip ring. So it is based on Fleming's right hand rule. Here again, central finger is the induced current. So here current is not provided, it is generated. The forefinger is a field, magnetic field, and the thumb, which is mutually perpendicular to both of them, is the motion of the conductor. So here the mechanical energy is converted to electrical energy. So that's the principle behind it. Mark the definition, learn the principle. Construction is a read and even the working is a read, but let's understand how it works. So first we keep the plane of the coil perpendicular to the magnetic field, which is very different from a DC motor where it started off as parallel. So imagine there is a magnetic field from left to right, as you can see in the diagram, from North Pole to South Pole, North Pole to South Pole. And I'm going to keep the area of the coil perpendicular. So some magnetic field lines are passing through it. Let's say 5 lines are passing through it. That's called the magnetic flux linked with the coil. Now just give it a gentle push. Use some device to rotate it. It could be wind, for example. When it starts rotating, now the number of magnetic field lines passing through the area will be less. See, when it was perpendicular, maximum surface was exposed to it. But once it becomes a bit inclined, now less area is available. In fact, when it becomes parallel, very less areas, there is no magnetic field line passing through the thin wire. Only when it is perpendicular will the maximum magnetic lines pass through it. I will try to incorporate an animated YouTube video for better understanding. So whenever there is a change in the magnetic flux linked with the coil, electricity is generated. That's the whole principle behind it. So as you rotate it, electricity is produced. And it is being produced in the direction of A, B, C, D. Notice that at any point AB is connected to brush B1 because of this slip ring. Even when it is rotating, it doesn't lose its connection with B1. And CD is always in connection with B2 brush thanks to the slip ring S2. Even when it's rotating, the connection is never broken, unlike the split rings in the DC motor. So initially less current is produced because from 5 magnetic field lines it decreased to 4. So some current is produced, but maximum current is produced just when the area of this coil is parallel to the magnetic field, because from say 2 magnetic field lines, now it is 0. 0 lines are passing through it because it is parallel. So current produced is maximum, and the direction of the current is A, B, C, D here, and in the outside circuit it is from brush B2 to brush B1. It continues its rotation, the clockwise rotation, and again the current magnitude decreases. In fact, when it completes 270 degrees, notice how the direction of current is now DCBA. The direction of current has changed, not only in this armature coil, but even outside. Now the current is flowing from B1 to B2. So that's how alternating current is produced. The direction of current keeps on changing, even though the rotation is in the same direction, that is clockwise rotation. So remember here, maximum EMF is produced at 90 degrees and 270 degrees when the magnetic field lines passing through the area of the coil is 0 or minimum. And the minimum EMF is produced at 0 degrees and 180 degrees when there is hardly any change in the magnetic flux. You see, when the coil is at 90 degrees, okay? So when it rotates from here to here, there's hardly any change in the number of magnetic field lines passing through it. That's why we have the sine wave out here. The EMF of an alternating current is never a constant. The direction changes and the magnitude changes both, unlike DC. So from 0, 90 degrees position of the coil is a maximum EMF. At 180 degrees, it's minimum 0 EMF. And the direction changes at 270, it's again peak, and so on. Notice that when I say 90 degrees, I mean 90 degrees of rotation, not position. Here, when I say 90 degrees rotation, but the area is parallel to the magnetic field. And here it is perpendicular, but the position is after 180 degree rotation. 180 degrees compared to the initial position, which was already perpendicular to the magnetic field. These notes are always very important, learn them. And finally, transformer. Well, again, the working is a read. Construction is a read. Principle. Well, the principle is that it works on electromagnetic induction. Its function is to change the magnitude of an alternating EMF, especially when you are transporting electricity. You know, if you first step up the voltage and then step down it once it reaches the down, which is explained in chapter 9 in detail. Now, there are some give reasons which have been marked. The core should be laminated to prevent loss of energy due to eddy currents or induced currents in the core. So the transformer is always laminated. Second, we should use a closed core. So again, there is a minimum loss of energy. That's all we need to write in exam. Also, make the core of soft iron, obviously, because it ensures there is loss of energy, minimum loss of energy due to hysteresis. So there are 3 ways in which we try to reduce the loss of energy. We don't have to know this in detail. That's college level stuff. Now, look at the step up transformer. You see, this is the secondary coil, and this is the primary coil. I can see the number of coils in the primary coil is less compared to secondary. Now, because the current is flowing through the primary coil, it has its own magnetic field, which permeates the entire region. So even the secondary coil, which has no current, by the way, nothing, it is surrounded by the magnetic field of the primary coil. But because the current in the primary coil is fluctuating, it's alternating current, the direction is changing, the EMF magnitude is changing. So the magnetic field produced by it is also fluctuating. And whenever the magnetic flux linked to the coil changes, electricity is induced. So in this case, we are not moving any core or any wire or the magnet. We are just changing the magnitude of the EMF to have the same result. Induction of electricity. They're not even touching each other, but electricity is induced in this. And since the number of coils is more, the voltage will be more, the EMF will be more. It's called a step up transformer. Of course, the current will be less so that the total electrical energy remains the same. We can't get electricity for free here. A step down transformer works similarly, but here the secondary coil has less number of turns, so the voltage will be lesser than what it was in the primary coil, but the current will be more. Another note here, we should use thicker wire of coil to reduce the loss of energy. So that's a 4th way to reduce the loss of energy in transformers. Remember, if the number of coils in the secondary coil is less, then the current in the secondary coil will be more, although the voltage will be less. There are no numericals, so cancel all of this. Uses have to be learned, yeah, and differentiate is also there. Solved examples and exercise, the best. This chapter particularly, amazing solved examples and exercise. Everything will come only from there in any test. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.